Welcome to the next module, and in this particular lecture I'll be talking about the intuition behind association learning, and the model we are choosing or the algorithm we are talking about is a priori algorithm. So in this particular lecture we'll be talking about what a priori algorithm is and what are the association matrices that we have to find out the association between two different items. So what is a priori algorithm? This algorithm is basically used to find out the frequent item sets in a data set. So for example, you go in a mall, then you can clearly see that you have bread and eggs placed together, honey, sugar, coffee, all these products are placed together, whereas rice, pulses, and the spices are placed together. Why is it so? Because they have find out the association between the items that people bought from a supermarket, right? So as per the rules or as per the calculations, they come out with a solution that if a person buys a dairy product, he is more supposed to get a bread with it or a butter with it or egg with it, right? And if a person takes pulses, then he is supposed to be having spices or rice also with it. So these are some association rules that are very important for supermarkets to increase their sales, right? So that's where the a priori algorithm come into picture, or the association rule mining come into picture. Then we have to find out the frequent item sets in our data set, right? So let's understand how the stuff works. So to find out the association between different items, we have to come up with some matrices, right? So these are 5 different matrices that we have, right? So support, confidence, lift, leverage, conviction. And now I'll tell you how these matrices work, what is their significance, and what intuition we can have using their values, right? So first of all, we'll be talking about the association rule and the matrices involved. Then we'll see how the a priori algorithm brings all these association rule to picture and finally works upon. Okay. Support. Support means how frequent an item set is in all the transactions, right? So if we have different items in our supermarkets, for example, egg, bread, jam. So to count the support of the item egg, what we have to do is we have to find out that how frequent this particular item is in respect to all the transactions. So the number of transactions which have egg and the total number of transactions including those having egg and including those which are not having egg. So with egg plus without egg. So all the transitions in the denominator and only the transitions with egg in the numerator. So this is kind of a ratio. So we can find out how frequent this item is. Suppose for example we have 9 transactions in which we have egg out of 10. So the support of egg is 0.9, or you can say 90%. Similarly, if we have only 2 transactions in which we are having egg and there are total of 10 transactions, then we can say that we have a support value of 20% for the egg. That means that this particular supermarket is having more frequent sales of egg as compared to this particular supermarket, right? So this is support. Now we'll talk about the confidence. Confidence is that the likeliness or the probability of occurrence of a consequent on a cart given that the cart already has an antecedent. So what I mean to say is this A means antecedent, right? Antecedent, and this C means the consequent. Okay. So if I say suppose confidence of bread over butter. So what that means is, so it means the likeliness or the probability of occurrence of bread of butter, sorry. So what it means is, suppose I have butter, then what is the probability that a customer will buy a butter, or what is the probability of occurrence of butter in the cart given that the customer has already bought bread, right? So we have to find out the correlation between two items. So what is the probability of a customer buying C if he or she already has bought the product A, right? So we have to find out the occurrence of C with respect to the A. That means that C is dependent on A for its sale. So that means we are finding out the probability, that what is the probability of the sales of C given that the customer has already purchased the product A. So confidence of A to C is support A to C by support A, right? So support A to C means all those and support of the transitions where we have A and C, right? So we'll say support A and C by total transitions upon support A means transitions in which we are having only A upon total transitions, right? So this is more or less AC by A transitions, right? So this is how we calculate the confidence. That is the probability of A or C being together considering A is already present. Going to the next matrices, we have lift. So lift means the measure of how much more often the antecedent and consequent of a rule A to C occurs together than we would expect if they are statistically independent. So what it means to say is that it finds out the togetherness of the two items considering that A has no correlation or no relation with C. Keeping the two products independent of each other, it is there to find out the togetherness or the relation between the sales of these two products, right? So for that, what it does is it divides confidence of these two products with the support value of the consequent. So what it is doing is it's comparing the correlation between these two values A and C by considering that these products are already independent. And if A and C are independent, then the lift score would be exactly 1. So if we have a lift score equal to 1, then we can say that these two products are independent of each other and they have no correlation in between them, right? Then we have leverage. What leverage means is it computes the difference between the frequent values of A and C appearing together and the frequency that they would appear independent of each other. So for that, it calculates the support value of A and C minus support value of A into support value of C, right? So if we are getting a zero value, that means these two products A and C will have no relation between them. They are independent of each other. Coming up to the last of our matrices, we have conviction. So conviction means that the consequent is highly depending on antecedent, right? So we have to find out how much the consequent is dependent on antecedent for its sale. So for example, if I am saying that we are talking about suppose bread and egg. So conviction means that how important is the sale of bread for the sale of egg. So for that, what we have to do is the formula is 1 minus support of C divided by 1 minus confidence of A to C. So if in case we have a perfect confidence score, then in that case this confidence of A to C will be 100%, right? So it will be 1. So 1 minus 1 will be 0. So denominator will be 0. Then in that case we have a conviction score of infinity. That means that consequent is totally dependent on incident for its purchase or for its sale. So that means they are highly correlated to each other. Consequent is highly dependent on antecedent for its sale. Right? Similarly, if the items are independent, then the conviction is 1. Okay. So that's all about matrices. These are some of the matrices, or these are some of the values which we consider when you are finding the association. Each of this is having different intuition, as I have explained. So as per our choice and as per the intuition we want or what we are expecting, we choose the matrices accordingly. So now we'll see how we can use these matrices in our a priori algorithm. So suppose we are given a data set where we are given these transitions number, and these are the items that a person has bought in these transition. So this is the data set, and then we have to consider the association matrix. So the association we are considering is that we want a minimum support count of 2 and a minimum confidence should be 60%, right? So now according to our association, we perform our a priori algorithm and we reach up to such frequent items. So the basic intuition behind doing all this is that to have a very frequent superset, the subset needs to be frequent also, right? So basically, to reach up the higher level, it's very important that the lower levels also should be strongly associated with each other, right? So what we'll do is we'll first count the value of these transitions. So let's say we are counting the support count of these values. So L1 is 6, L2 7, L3 6, L4 2, and then L5. Okay, that's just a random data, and these are just a random examples. You don't need to calculate all this because that's a very less data, and I have just prepared it so that you can understand. Okay. So you can see that we are not having L6, L7, L8 and L9 because they were having less support value. So I removed these values. So we are left with these 5 items only. Now what we'll do is we'll find out a pair of all these values, right? And we'll check the support of all this. So we have L1, L2, L1, L3, L1, L4, L1, L5, right? So set complete. Then L2, L3, L4, L5, L3, L4, L4, L5, so set complete, and then L3, L4, L3, L5, set complete, L4, L5. So you can see that we have all the combinations with us right now. But in these cases, the support value is less, right? So we have to remove these values. So now what are the items we are left with? So we are left with only L1. Okay, so support is 2, so we have to we can remove these two also over here, these, because it's only 2, so we can remove these values also. Okay, so what we are left with, we are left with L1, then L2 and L3. Okay, so L3 and so now the support value of these values is less than 2, so we have to remove these values. Okay, so what are the items we are left with? We are left with L1, L2, L3, L4 and L5. Okay, so what we have to do is we have to basically find out the sets of this. So till now we have prepared a pair of 2 items, and we'll find a pair of 3 items. So L1, L2, L3, and then we again count the support, that is the transitions in which we have all the 3 items together by the total transitions we have. Okay, so that's how we calculate our L1, L2 and L3 pairs, and there will be so many pairs, but after calculating, suppose these are the 2 pairs that we have with us because they are having support value of 2 or more than 2, and then these values will be the associated items that we want. After finding out these values, we can find out the confidence of, suppose we can find out the confidence of L1, L2 to L3, L1, L2 to L5, right? And L1, L3 to L2, and such we find out the confidence value, and if they have a confidence value more than 60%, then we will consider those item sets and we can prepare our marketing strategy like this. For example, that we have two items, bread, butter, right? So if they have a very high confidence value, say 80%, so we know that if a person buys a bread, then the person is already buying butter also, right? And if we have, suppose, say bread and jam, so we know that a person is buying bread but he or she is not buying jam, because in that case it has less confidence value. So we can put up an offer on this particular item set that if you buy a jam you'll get a bread also, right? Or we can say that if you buy 10 breads, then you can buy, then you will be having a free jam, one free jam with you. So this is how the strategies are planned in supermarkets so that they can increase up their sale by finding out the patterns or the behavior of the customers. So this is all important when we are talking about association mining. That is, we find out the association or the correlation between two items and we predict the customer behavior, that if a person is buying this item, then he is this much probably, or with this percentage we can say that he or she will buy this product also. So this was all about association rule and a priori algorithm. So thank you for watching this video and keep following. Best of luck. In the next coming lecture, we'll be talking about how we can perform this a priori algorithm using a Python code.